Hello everyone. This video would focus on conic section, specifically on parabola with vertex at HK, and this is the fifth part. In this part, we're supposed to determine the equation of the parabola given the coordinate of the focus and the equation of the directrix, and we're supposed to sketch the graph. Before we go over this example right here, let's have a review on the basics of parabola with vertex at HK. We remember that there are 4 cases of a parabola with vertex at HK. But before we dive into these 4 cases, let's have the parts of every parabola. The first part that we need to remember is the vertex. So this is located right here. So this is our vertex, and this is actually represented at HK, coordinate HK. Another part that we have is the focus. So this is our focus right here. Now we remember that the location of the focus from the vertex determines where the parabola opens. If the focus is located to the right of the vertex, that means that the parabola will open to the right. On the other hand, if the focus is to the left of the vertex, then the parabola opens to the left. We also remember that the distance from the focus to the vertex is represented as P. And this is also P right here. Another part is the ends of the Latus rectum. So these 2 points that we have here are the 2 ends of the Latus rectum. We need these 2 ends in order that we can graph the parabola from the vertex. Okay, now we remember that the distance from the focus to one end of the Latus rectum is 2p. So I'm going to go ahead and write that up here. We also remember that this value of p here, which is from the vertex to the focus, this value right here will be negative. The reason for that is because it's going to the left. While on the other one right here, the value of the p is positive because it's going to the right. Now, another part that we need to remember is the directrix. So this is the directrix right here, represented in a broken line. Now, we also remember that the distance of the directrix from the vertex is also P. So I can go ahead and label that up here. This tells us that the vertex is actually in the middle between the point where the directrix passed through and the focus. So the vertex is in the middle of these 2 points. Another part of the parabola is the line of symmetry. The line of symmetry will always pass through the focus and the vertex. So this is our line of symmetry. On the right, you will see the first case. I labeled it as case 1, and that is when the parabola opens right. And well, case 2 is whenever the parabola opens to the left. For these 2 cases, the equation that we are going to use every time will be quantity y minus k squared equals 4p quantity x minus h. So this is the equation that would work for these 2 cases. We remember that the sign of the p matters between these 2 graphs. Whenever the p is positive, it opens to the right. Well, if the p is negative, it will open to the left. So they're pretty much the same thing, but the p matters because it determines where the parabola opens. Now let's have the third and the fourth case. The parts of the third and the fourth case are pretty much the same thing. We have the vertex. We also have the focus. Now, looking at this for case 3, since we again remember that a parabola opens towards where the focus is from the vertex. Since from here, our focus is located above the vertex, then the parabola opens up. In this case right here, since our focus is below the vertex, then that means that the parabola will open down. Again, we remember that the distance from the vertex to the focus is represented as P, And so from here, we can go ahead and say that the p-value here is positive because it's above the vertex, while the p here is negative because it's below the vertex. Now, the other parts would be the ends of the latus rectum. So we're going to need these 2 points together with a vertex so that we can sketch the parabola. Now, we remember that the distance from the focus to the end of the latus rectum is 2p, and this is also 2p. The same thing for this one right here. This is 2p and 2p. Another part is the directrix. We remember that the directrix is always located opposite to the focus from the vertex. So it's going to be opposite to the focus from the vertex. And then we also have another part here is the line of symmetry. So the line of symmetry is a line that passes through the focus and the vertex. For cases numbers 3 and 4, the general equation of the parabola would be quantity x minus h squared equals 4p y minus k. This is the formula that would work for these 2 cases. Case number 3, when the parabola opens up, and case number 4, when the parabola opens down. We remember that if the p is positive, then it opens up. And when the p is negative, then the parabola opens down. Okay, going back to the problem right here, we're supposed to determine the equation of a parabola with focus at -3, 2, and with directrix x equals -9, and we're supposed to sketch the graph. So the first thing that we're going to do here is to plot the focus and write the line for the directrix. So this is how it's going to look like. So the focus is on -3, 2, so that's -3 up to. So this is where the focus is going to sit. So I'm going to write this as, label this as focus. And then our directrix is x equals -9. So on the x-axis, we go all the way to 9. And we're going to draw the line for the directrix. We remember that the vertex is located in the middle between the focus and the directrix. It's going to locate it in the middle of these 2 at the line of symmetry. So I'm going to go ahead and write that statement up here. Okay, so looking at this, the middle between this focus and directrix is located this point. So this is our vertex. So I'm going to label this as V. So the coordinate of the vertex, therefore, is, that's going to be -6, 2. So I'm going to write that up here. So it's -6 and 2. Looking at this, we can go ahead and say that our parabola opens to the right since the focus is to the right of the vertex. This means that the parabola is going to go open this way. So I'm going to write that statement up here. Since this parabola opens to the right, we can go ahead and say that this is an example of case number 3. So we're supposed to determine the value for P. So the P is the distance from the vertex to the focus. So in this case right here, we have 1, 2, 3. So our P is 3. Please notice that we take a positive value for P because the vertex, or because the focus is to the right of the vertex. I'm going to label that up here. Okay, so then from here, we can go ahead and write the general equation for case number 1. So this is the general equation for case number 1. So what are we going to do is we plug in the value for the HK. Again, this is the vertex. So this will be our H and this will be our K. So we're going to plug in the value of the H, put in the value of the K, and put in the value of the P. So this is how our equation is going to look like. So this is the equation of this word problem that we have up here. But we're supposed to be sketching the graph of this parabola. Now we remember that in order that we can do that, we need to determine the ends of the latus rectum passing through the focus. Now we remember that one end of the latus rectum has a distance of 2p from the focus. So I'm going to go ahead and write that up here. So the value is 6. That means we count 6 spaces up and 6 spaces down to determine the ends of the latus rectum. So these are the ends of the latus rectum, and this is their corresponding coordinates. So that from here we can go ahead and sketch the graph. So this is the graph of this problem that we have right here, and this is the equation of this graph. Now we remember that the line of symmetry is a line that connects the vertex and the focus. So I can go ahead and draw that line of symmetry up here. So we have solved the first problem. Now let's move on to the second problem. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we're going to go over the problem here. We're supposed to determine the equation of a parabola with focus at 2, 2, and a directrix of y equals 6. And we're supposed to sketch the graph. So we're going to draw the focus and the line of the directrix. Okay, now we remember that the vertex for every parabola is located in between the focus and the directrix at the line of symmetry. So I'm going to go ahead and write that up here. So if you notice, I plotted the point for the vertex that's halfway between the directrix and the focus at the line of symmetry, so that we can go ahead and say that the coordinate for the vertex of this problem is gonna be 2, 4. So I'm gonna write that up here. Looking at this setup that we have here, we can tell that our parabola opens downward because again, our focus is located down from the vertex, and we remember that every parabola will open towards where the focus is. So the parabola is going to open downward. So I'm going to go ahead and write that up here. So this problem is an example of case number 4 because this parabola opens downward. Now we remember that our value of P is the distance from the vertex to the focus. So counting this, that would be 1, 2. So that would be a 2. But then we are taking a negative value. The reason for that is because the focus is below the vertex. So I'm going to go ahead and write that up here. So we're now ready to determine the equation of this problem right here. So we go ahead and say that since this is case number 4, I'm going to write the general equation for case number 4 down here. Now we remember that our HK is represented by the vertex. So this is our H and this is our K. So we plug this H here and this K value here. And so we plug in the value for P as well. So this is how the equation is going to look like. So this is the equation of this word problem right here. Now we're ready to sketch the graph. We remember that we need 2 points, which are the ends of the latus rectum passing through the focus so that we can sketch the graph. We remember that one end of the latus rectum has a distance of 2p from the focus. So I'm going to go ahead and show that work down here. So this value of 4 that we have right here means that we count 4 left and 4 units right to determine the ends of the latus rectum, and we are supposed to determine what that coordinate is. So these are the 2 ends of the latus rectum, so that from here we go ahead and sketch the graph. So this is the graph of this equation that we have down here, and this is the equation of this problem that we have up there. Now we remember that our line of symmetry passes through the vertex and the focus. So I'm gonna go ahead and sketch the line of symmetry up here. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!